This, I think, is quite a challenging question, especially it's not even right at the end of the paper, and it expects you to really know your sine curve and some transformations and some exact values of trigonometry well. All right, so we have a calculator. We can't even put in values. You basically have to know what sine x looks like in this question. It starts at 0. Sine x is 0. You might know some other ones. Actually, sine 90 is equal to 1. And then it comes back down and it hits 0 at 180, then it becomes -1 at 270, and then it hits 360. So those are some key values that are really well worth knowing. And then it looks like a wave essentially, so it just goes up, down, down, and back up. I really should have hit that one there, but I think I'll be okay. And that's it. That is our answer. Write down the coordinates of the maximum points of y equals sine x. Well, I've already spoken about it. It's this one here. That's when it reaches the maximum, and it's at 90 degrees. And then y is equal to 1. So the maximum of any of sine and cos are both 1, and the minimums are -1. Write down the coordinates of the maximum point of y equals 3 plus sine x. Well, when you add 3 to sine x, all you're doing is you're adding 3 to every single value. So every value will just jump up by 3. So this will move up to here, this will move sort of off the page, and you'll get it kind of, some sort of curve like a bit like this. And what will happen to the maximum? Well, the maximum will jump up by 3 as well. It will stay in exactly the same place, 90 degrees, but now I will add 3 to it, and it will be at y equals 4. It's quite a tough question, I think, but it's only a 1 marker. Right, one solution to the equation 4 sine x equals k is x equals 60. Find the value of k. Don't like this at all. So a solution is x equals 60. Well, let's work out what sine 60 is. And you have to know this. There are a few ways you can do it. There's like a nice memory technique that you can use for sine, cos, and tan. And I'm only going to do it for sine here. So the key angles you need to know it for are 0, 30, 45. I've just realised I've not left enough space. 60 and 90. Just about to see that 90. And then what you do is you just write the numbers 0, 1, 2, 3, 4. You square root them. It's just a memory technique. There's no logic behind this other than the fact that it will work. You divide by 2, and those are actually your exact values. So for sine 60, it is the square root of 3 divided by 2. And therefore, if we're trying to find out what k is, then I can rearrange this so I've got this here, but then I'm rearranging the top one, so sine x is going to be k divided by 4. So what is k going to equal? Then like this. Right, so what I'm going to do is I'm going to take the first term and I'm going to times top and bottom by 2. So that's going to give me 2 root 3 over 4. And now I've figured it out. Because I've got them basically the denominator the same, it must be that k is equal to 2 root 3. I think that's how you have to do it. I can't think of any other way of doing it. You need to know your exact value of sine. You need to, you write it as root 3 over 2. You compare it with k over 4, and you just figure out what k must have equaled. And that is the answer. Find another solution for x in the range 0 to 360. Well, we've just found this solution here. Okay, so when x is 60, we get root 3 over 2. That's actually not important for this question. What this question wants us to understand is the symmetry of the sine curve. So another solution is going to be if we carry on and go down here, and actually the curve can really help. The answer is going to be 120. How do I know that for sure? Just, it seems like it looked like it from the graph, but can I really be sure? Well, if if we think about the symmetry of the sine curve, this is a nice smooth curve, and this is 60 degrees away from 0. It's perfectly symmetrical about 90 degrees. And so 180, if I go back 60 degrees this way, then that will be where my other solution is, and I get 120 that way. I'm saying this because this will definitely be useful if you were to go on and study maths at A level, for example. You would be expected to deal with things like, if sine 30 is an answer, whereas another answer would be 150, and there's lots of other ones you could get negative ones as well. But in this case, I mean, this is how it works, but I have done it from the graph as well.